Example 3 wants us to find the exact value of the log without using our calculator. If you want to Google how to put these in your calculator, you can, but these are not hard to do by hand. And by doing them by hand, they are going to make us rewrite these logs as exponentials. And that skill is really going to help us as we get further into this module when we're having to solve more complex log equations and exponential equations. So, yes, you can put these in your calculator and you can Google how to do that. But I really advise you put in the hard work and do this I don't even think it's that long of a way, but do it a longer way than pushing some buttons to get more practice. So what we're going to do with all of these is we're going to change them into equations. So log base 2 of 1, I don't know what that equals. So I'm going to make this equal x some unknown. And now I'm going to rewrite this as an exponential. So we go base to the other side of the equals will equal what's left over. This is the same as 2 to the x equals 1. Now, most of these, we are going to be using that property of when we have the same base, is that the exponents equal to each other. This is kind of the one exception. This is just a rule we have to know. What's the only number I can plug in here into x to make this equal 1? That has to be 0. Now, instead of circling or boxing this entire thing of x equals 0, I turned this into an equation. So my answer here is simply 0. So if we know how to put this in our calculator, log base 2 of 1 would equal 0. Okay, same thing, log base 8 of 8, we're not sure, so we're going to set this to be equal to x, and then rewrite this. This is 8 to the x equals 8. Now, this is another one kind of like this where you can just logically figure it out. What does x have to equal? Well, it has to equal 1, right? But as we go further here, we need to use that property of getting to the same base. And so they already have the same base. So this is the same as 8 to the first. So now when I cancel out my bases, we get x equals 1. Okay, on C, we're going to set this to equal x and then rewrite base to the other side of the equals what's left over. So we have 7 to the x equals 49. This is again another one. What does x have to equal? This is 2, right? If I do what I need to do down here below, that is 7 to the x equals 7 squared. Those cancel, and we get x equals 2. Okay, now all of these, especially this one, because we don't have a way to write these as the same base, but these two here, you can just rewrite it and see what the answer is. Kind of starting down here, it's not quite as clear once we rewrite them. So we're really going to have to follow this rule of getting to the same base. So if I set that to equal x and we rewrite base to the other side of the equals is 3 to the x, and that's going to equal what's left over, which is 1/9. Okay, I can see here my common base is going to be 3. So if I first rewrite 9 with a base of 3, that is 3 squared. But here we have a base of 3 and really kind of a base of 1/3. So to change this to become a base of 3, we can move this back up and change this exponent to negative. So 3 to the x equals 3 to the negative 2. And now we have the same bases. And we get x equals negative 2. Very similar on this one. So this equal x. And we are going base to the other side of the equals what's left over. So 1/5 to the x power equals 1/25. Okay, we need to get to a common base. These will both have a base of 5. How can I rewrite 1/5 to the x power with a base of 5? Very similar to this right here. When this was in the denominator, we moved it up and changed the exponent negative. This is in the denominator, we're moving it up. So I'm going to change this x to a negative x. And then if we don't know this one, we know 5 squared is 25. So if I start at 5 cubed, there it is. So now we can cancel. And I've got negative x equals 3. So therefore, x equals negative 3. On f, if I set this to equal x, rewrite it as an exponential, this is a common log. So the common log, that means we have a known base of 10. So base to the other side of the equals what is left. We have 10 to the x equals the square root of 10. Now these are very close to having the same base. This is where that rational exponent comes into play. How can I rewrite the square root of 10 with a base of 10? Well, this is the same as 10 to the first, and my index of a square root is a 2. So if I rewrite it, your exponent is your numerator, and your denominator is your exponent here. So anything to the square root is to the 1/2 power. Now we have the same base, and so we get x equals 1/2. Now it says specifically don't use a calculator, but because this is a common log, we can put this one in our calculator and we should get the same answer. So if I put log of square root 10, we get 0.5. Truly the same way on this one here. If I do log of the cubic root of 100, we're going to get 0.6 repeating. Do you know what that is as a fraction? Because my math lab wants fractions. If I go math and change it to a fraction, we get 2/3. So how could we do that by hand without using the calculator? Set this to equal x. Common log means I have a base of 10. So when I rewrite this, I get 10 to the x equals the cubic root of 100. Now I know my base here needs to be 10. I can rewrite 100 with a base of 10. That would be 10 squared. And now I can rewrite this as a rational exponent. So this would be 10 to the x, 10 to what power? This exponent here is the numerator, and whatever the index is my denominator. So my bases cancel, and I get x equals 2/3, which is exactly what we got. Here, set this equal to x. Rewrite this, natural logs have a base of e. So base to the other side of the equals what's left. We have e to the x equals equals the square root of e. And let's skip the step. Rewrite that square root as a rational exponent. So that will be e to what power? Known 1, known 2. That is to the 1/2 power. And if we cancel our same bases, we get x equals 1/2. Again, natural logs are one of the 2 buttons we have here. So we can do the natural log of the square root of e, and we get 1/2 as well. So same thing here, we can put that in. The natural log of e cubed is 3. Why? When I rewrite this, So set that equal to x and rewrite. This is a natural log with a base of e. So this is e to the x equals e cubed. Rewriting it, we already have the same base. So we get x equals 3, which is exactly what we got here.